Okay, let me explain now a problem about intersecting lines. So I give you the equation of two lines. Again, you can give the equation of a line in terms of this vector format. So they are given in terms of t, and I want to know if whether or not they intersect. So what you should have in mind is that here's the first line. Here's the second line. And we want to find this point of intersection. Now, this is actually the only subtle point about this problem. So what can we say about the first line? Remember that for the first line, at time t equals 0, you get 2, 4, 6. So maybe here is at time t equals 0. Well, you cannot take this picture too literally, but I say at time t equals 0, the particle is there. At time t equals 0, the other particle is at 1, 5, 7. Right? But I mean, they're traveling at different velocities, and they may start from different places, right? So there's no reason, even if the lines intersect, that doesn't mean that the particles themselves will collide. That's a different question. Like if they were to collide, they would have to meet here at the same time. We're not requiring them to meet at the same time. We're just requiring that throughout their trajectories, they did go through the same point at least once. And if it happens once, it cannot happen any other time because they're lines, so they're not allowed to bend again. And so really, the main idea is that they can meet at this point. Let's call it I for intersection. The lines can pass through I, or the point, or the particles, maybe I should say, can go through I, point I at different times. Okay? So what that means is that maybe for the first particle, you went through this point at time t1, but for the second particle, you went through this point at time t2. So there's no expectation that the times have to be the same. And so really what we're asking is whether or not we want to find out whether or not the trajectory at time t1, the point that you would get at this time t1, is the same as the point that you would get at time t2 for the second line. Right? If they pass through the same point, the position vector has to be the same. We're just saying that they are the same vector, or they're the same point, but not necessarily at the same time. And so this gives you a system of equations and which we can now solve. And remember, as a vector, this is like an equation between vectors, but the nice thing about working with vectors is that they secretly give you many equations at the same time. So these are obtained by setting equal the corresponding entries. So before the glitch, I was saying that you set up the corresponding entries. So t1 plus 2 equals minus t2 plus 1, and then you get minus t1 plus 4 equals t2 plus 5, and then you get 2t1 plus 6 equals t2 plus 7. And so, for example, the first equation says that that t1 equals minus t2 minus 1, right? And so if you replace this into the other equations, what do you get? You get minus t1, which would become t2 plus 1 plus 4 equals t2 plus 5, and that just gives you, right, both sides are the same, that just gives you 0 equals 0, which is fine, but it's not useful. And then if you do the same for the last equation, you get 2t1. t1 is this, so you get minus 2t2 minus 2 plus 6 equals t2 plus 7. And here you get, this becomes 4. So when you move the 7 to the other side, you get minus 3. And that gives you t2, 3t2. And so you get that t2 equals negative 1. But if t2 equals negative 1, that means that t1 equals what? Equals 1 minus 1 equals 0. Okay? So those are the values that you need to work with. And so the position, the point where the lines intersect, can be obtained by using any of these values. So for t1, for the first equation, you use times 0, so you get 246. For the second equation, you use time equals negative 1, and you get 246 again. So the system is consistent in the sense that it did not matter which equation you use to find the point of intersection. And that's something useful to keep in mind. So if you had not tried to solve the system, if you had tried to solve the system with the same value of t on both sides, you would have found something impossible, like say 0 equals 1, instead of getting 0 equals 0 at some point. So in general, when you're working with a system of equations, you need to make sure that you, when you do all the substitutions, that you cannot reach something stupid, and that will guarantee that there's a solution. Okay. So next time I'll tell you about planes and how to find the equations of planes and why they will be useful.